Hi everyone. In this video session we are going to attempt next question of computer organization, and this question was asked in the year 2014 in set 1 for 2 marks. The question is, an access sequence of cache block addresses has length capital N and contains small n unique block addresses. The number of unique block addresses between two consecutive accesses to the same block is bounded by k. What is the miss ratio if the access sequence is passed through a cache of associativity capital A greater than equals to k, exercising least recently used replacement policy? And there are 4 options that are given. So here the data points that are given are capital N, which represents total number of addresses in the sequence, and small n is the number of unique addresses in the sequence. Number of unique addresses in the sequence. Number of unique addresses. So here few of the addresses might be repeated, right? And one more constant on the repeating values is given, that the positions of the repeating values cannot be greater than this positive constant, where the maximum value of this positive constant is equals to associativity of the cache. That means the position of repeating values cannot be greater than capital A. So let's take an example and discuss this. So let's say the associativity of the cache is 4. That means it is 4-way set associative cache. And let's say there is a cache and there are multiple sets in it, and this is the diagram of one of the sets. So it is 4-way set associative. That means it must be having 4 cache lines. So it is one of the sets, and there are such multiple sets in the cache. Now let's say the content of the set, whatever set it might be, is A1, A2, A3, A4. So 4 blocks are there with these addresses A1, A2, A3, A4, and A1 is the least recently used block, followed by A2, followed by A3, and A4 is the most recently used block. That means next time if a different block address comes, then A1 is going to be overwritten by it. So let's say after A4, so this is the sequence of addresses that we are accessing, and A4 has just got inserted into the cache, moved into the cache, and this is first occurrence of A4. First occurrence of A4. So one observation is that the first occurrence of a block would always result into a miss, right? Because it is not there, it has not got encountered till now, so there is no chance of it being already present in the set. So it would always result into a cache miss. Now let's assume that A4 is repeating value. That means it is occurring one more or few more times in the sequence, right? And after A4, these are the block addresses A5, A6, A7, and again the repeating value is at this position, and it also follows this constant that the positions of the repeating value must not be must not differ by anything greater than 4. That is the associativity of the cache. So here A4 and this repeating value of this address is differing in the position by 4 places. 1, 2, 3, 4. So these are the repeating values and their positions differ from each other by 4 positions. Well, so what would happen now after A4 when we access A5 as, and also assume that A5, A6, A7 also maps to the same set. Now A5 would be overwriting A1 because A1 is least recently used. A6 would overwrite A2. A3 would be overwritten by A7, and now again we have this repeating value A4, and as it is already there in the set, so it would result into a cache hit, right? So what we can observe here, that instead of A4, had there been some other block address, then A4 would have got overwritten, and if again A4 would have been in the sequence, then A4 the repeating occurrence of A4 would have resulted into a cache miss. But because of this constraint that the positions of the repeating values should not differ by more than 4, that is the associativity number of the cache, that's why what we can say for sure that the repeating value, that means second occurrence onwards, any block address, for any block address, it would always result into a cache hit, right? So this is the observation. And the first occurrence, for first occurrence we have already concluded that the first occurrence of any value of any block address would always result into a cache miss. Second occurrence onwards, because of this constraint that the positions cannot differ by more than associativity of the cache, it would always result into a cache hit. That means only cache misses would be the first occurrences of the addresses, and there are n unique addresses, so there would be in total n misses in all, and the total number of accesses is capital N. So the cache the miss ratio would be small n, these many misses out of total number of accesses, that is capital N. So this would be the miss ratio, and so this would be the answer. So hope you have understood the logic behind choosing this answer. Thanks for watching. Bye.